Hello and welcome to the Automotive Diagnosis YouTube channel. This video shows you the procedure to remove and test the ignition coils on Nissan Versa. Please stay with us until the end of the video and support us by sharing the video and subscribing the channel. In this video I will show you how to remove the ignition coils, as they are under the intake manifold, so you have to remove the manifold first. We will have a look at the wiring diagram. Then I will check the power supply on the ignition coil. Next is to check the full-time ground. And to check the triggering signal on the ignition coil. And at the end I will show you to test the ignition coil itself. Let's start by removing the intake manifold to get to the ignition coils. Follow the procedure shown here to remove the intake manifold to get to the ignition coils. As you see, ignition coils on this engine have got 3 wires. So first of all, we will have a look at the wiring diagram to see what are those 3 wires. You see the wiring diagram for the ignition coils here. First of all, unline any other coils, there is a power supply on the ignition coil connector which must be battery voltage when ignition is on or engine is running. The second one is the full-time ground. It means that this circuit is not interrupted by any ignition control module like in a conventional ignition coil. But it is connected directly to the ground. because this coil has the ignition module integrated into the coil itself. So, this full-time ground wire is for the transistor itself. Another major difference of this type of coil-on-plug ignition system is that it does not receive a switching signal at all. It receives a triggering signal instead. In this type, the ignition control module is located inside the coil-on-plug ignition coil itself. In fact, it is a transistor that provides the ignition control module function. Thus, the triggering signal is the signal that tells this transistor the exact time to make the ignition coil spark. This signal can be tested by two methods. One is by using a multimeter that's capable of reading Hertz frequency. And the other is using an oscilloscope. Let's check the power supply on the ignition coil connector. Use a multimeter and check the voltage between pin number 3 and the ground. Make sure you have the battery voltage when ignition switch is on. If power supply was okay, go to the next step to check the full-time ground. As this wire must be connected directly to the ground, you can check the continuity between the pin number 2 and the body ground using a multimeter. In this test, continuity must be existed. Otherwise, you must check the relevant ground or the wiring. In case you have the good ground, triggering signal must be checked. For testing the triggering signal, you can test the signal using a multimeter that's capable of reading Hertz frequency, or you can use an oscilloscope. But the easiest way is to check the continuity on the triggering line between the engine control module and ignition coil connector, pin number 1. Make sure the continuity is existed. Pin numbers on the ECM connector are shown here for each cylinder. Remember that this photo shows the pin numbers from the back of the ECM harness gray connector. When ECM connectors are disconnected, you can check the short circuit between each wire on the ignition coil connector. So check the continuity between each two pins in the connector as shown here and make sure that there is no continuity. And the last step is to check the ignition coil. Because of the ignition control module inside the ignition coil, we are not able to measure the primary winding resistance, but we can have a measurement on the secondary coil as shown here. Replace the ignition coil if the internal resistance is abnormal. Thank you for watching this video. Please share the video if you liked it and don't forget to subscribe the channel for more videos.